Hey guys, welcome back. Day 14, more electron configuration. We are diving into some notable anomalies and exceptions to what the quantum mechanical model suggests should be the ground state electron configurations for these elements, and that's just, we need to cover them because that's what we observe. And remember, quantum mechanics is it's a fantastic model, right? It's a mathematical model, right, that represents electrons as waves and helps us predict behavior, makes us very knowledgeable on chemistry and chemical physics and a lot of technology advances, all good stuff, right? We need to know, though, some of these anomalies. And some properties actually come from these anomalies, so it's good to know. And there's ones that I expect you to know, ones that I'll tell you why they're the way they are, but I don't expect you to know. So let's dive into some that we expect you to know. Copper. Copper, if you look at copper, you would expect it to be argon, 4s2, 3d9. Right? Up here, Hund's rule. Half or completely filled degenerate d or f orbital sets are particularly stable, right? And so here's a good analogy for you guys. Maybe you've done this before. You've gone to a sporting game, right? And you go to a sporting game. Me growing up, and even me now, I typically don't sit like down. I sit up, right? Mainly because it's cheaper to sit up. So when you go, there's usually somebody helping you find your seats when you go down, right? And they're looking at your ticket and telling you, yep, you're over here, yep, you're over here. And they're really checking your tickets, right? They're also helping you, but they're also checking to make sure you belong there, right? Just avoid fights and whatnot. Well, a lot of times, like when I was a grad student or whatnot, I'd go to a major football game, and especially at the beginning of the season, sometimes it wasn't like a high intense competition, like it was a lopsided. Well, after the score gets out of hand a little bit, those people helping the lower, guys find their seats, they leave. All right, and so in the second half or whatnot, you can just mosey on down and sit in open seats down low, right, and get a better view. Right, we do that as humans sometimes, right? Well, the electron here, right, these electrons, some of the electrons in the 4s are actually in a higher energy. Even though they fill first, they're in a higher energy than the 3D. And so what we see is that it's still argon, still the same core, but it becomes 4s1, 3d10 to get that full d orbital, right? And that's way more stable, all right? And that kind of makes sense, right? Silver does something similar. So you would expect silver to be krypton, 5s2, 4d9, and we expect it actually is krypton, 5s1, 4d10. Same thing with gold. Gold, right? We're in period 6, so you got xenon, 6s2. Don't forget the 4f14 in there, 5d9, and we actually get xenon, 6s1, still 4f14, 5d10. All right, chromium is another one that I'll expect you to know. Chromium makes sense. All right, so chromium, right, we're back in period 4, so we have argon. Then we think it should be 4s2, 3d4, right? 3d4. However, half-full d orbitals are also stable. And d4 is not half full, but d5 would be half full, right? And so we actually get argon, 4s1, 3d5. All right. Okay, what other ones, right? I'm going to skip down to palladium. All right, PD. And PD, if we look at PD palladium, right, number 46, we think it should be krypton. And it should be 5s2, 4d8. Well, what do you think happens? Again, full orbitals. We get krypton, 5s0, 4d10. Now, I have a lot of students ask me, do I have to put the 5s0 down? No, I'm okay if you leave it off, all right? However, for our learning purposes, I think it's a really good idea to have it there so we know that it's 5s0, all right, that we didn't just forget it, okay? Now, the rest of these, all right, let's dive down to d orbitals and splitting, okay? And so if we have the 5 d orbitals, and I'll just 1, 2, 3, 4, 5. I have 5 d orbitals, right? What happens here is that the d orbitals, depending on their shape, they split. So the first shape is tetrahedral, and we'll learn about that later on. All right? And it splits into 3 of them up top and 2 of them lower in energy. All right? So if we had energy here this way, if this was energy, right, you have, right, dxy, dyz, dyz, and dxz up top. Then you have dx squared minus y squared and dz squared down there. All right. If the shape happens to be octahedral, these flip basically. All right, you have x squared minus y squared up there, dz squared up there, then you have, right, xy, yz, and xz down there. And there's another shape called square planar, all right, and that one's different. You got 2 down here, 1 here about, 1 here about, and 1 up here. And you have yz and xz on the bottom. You have z squared down here. You have xy here, and you have x squared minus y squared up there. All right, why am I showing you this? This is not really a big Chem 1 topic. Okay, sometimes some Chem 2s talk about it, but you know, when you get to, if you get to coordination chemistry, which is fantastic, but I'm showing you this because how electrons fill, right? So I can have D1, D2 be half full because these d orbitals on the bottom are lower in energy. And I can have D4 actually be half full. And I can have D5, 6, I can have D7 be half full. Octahedral, I can have D1, 2, 3, 4, 5, 6. I can have D7, 8. So I can have 3, 6, or 8 be stable. All right, square planar, I can have D1, D2, D4, D5, D6, D7, D8, D9, and D10. Right, so I can have all those be full and half full. Right, so it gives you some anomalies. So if we go back up here while we're doing this, ruthenium, if you look at ruthenium, ruthenium should be krypton, 5s2, 4d6. But it is krypton, 5s1, 4d7. And so there are a couple options down here. And we're not going to get into these, right? I don't expect you to know, oh, that's tetrahedral, that's square plate. Don't worry about any of that, okay? I just want you to know there is a way for D7 to be full or half full in this case. Half full in this case, all right? You not, again, these ones, the ones I do in purple here, I'm going to show you, you're not going to have to memorize and all that. I just wanted to show you that they are that way, okay? Rhodium. Rhodium is krypton, 5s2, 4d7. But what it actually is krypton, 5s1, 4d8. Platinum, another one. All right, platinum, we would expect it to be xenon, 6s2, 4f14, 5d8. Well, we expect it almost to be the same as palladium, but it's not. Xenon, 6s1, 4f14, 5d9. So platinum square planar. All right, it likes to be, at least. And B here, we think it's supposed to be krypton, 5s2, 4d3, and in reality it is krypton, 5s1, 4d4. Right, these are difficult, right? If you don't know all the d orbitals and that stuff, and we're not there yet, and I don't expect us to be there yet. Molybdenum, finally krypton. We think it should be 5s2, 4d4. And this one is one we would expect to know because it is krypton, 5s1, 4d5, and we expect 4d5. So that's expected. All right. So how am I supposed to know which ones to know? Well, ahead of you. You have this. All right. And so the ones that I want you to know are in this like orange highlight. The ones in blue are for your information in this course, right? Obviously, if you go to different courses, it might be different. Okay, and so that's the valence-ish electron configuration for all the elements. And if you look at the exceptions, right? All these exceptions down in the F block, right? There are more exceptions than rules, right? Because you got so many electrons and it's very complicated, which is fine. All right, so I expect you to know these 4 and these 2, right? Because they make sense. They're stealers. So in group 6, because it's D4, but it's really D5. And D10, D10. That's it. Everything else is pretty straightforward. So hopefully by now you've figured out all group 1 is S1. All of group 2 is S2. Right? 3 should be D1. 4 should be D2. 5 should be D3, but it's not. 6, it's D4, but some of them are D5. 7 is D5. D6, but they're getting exceptions. D7, exceptions. D8, but there are exceptions. Oh, this is wrong. This should be 4S1, 3D10. Make a note of that. Make a note of that. Caught that typo. Sorry about that. Then you have D10. Then you have P1, P2, P3, P4, P5, P6. Right? And so that's the electron configuration of everything. Hopefully that makes sense. Right? And now, we talk about periodic trends and properties since they have very similar electron configurations vertically, and there's patterns going vertical and horizontal. There's a lot of trends that we get to talk about. Right? And it also makes sense to why everyone here is +1, +2. A lot of times this is +3, right? Right? And they can be +2 or +4, right? But these are +3. Some of them are +1 and 3. Plus or -4 or +2 and 4. -3, -2, -1. No chart. Hopefully that makes sense now with the electron configuration. All right. Well, with that, ladies and gentlemen, take care, and we'll see you.